Welcome to the Wildlife Wire. I'm Mark Searles,
And I'm Samantha Miller.
and this is your source for wildlife news and the people that make it. On today's episode, Doge is at it again. Colorado wolves are back in the news, and don't hold your breath for a story about seals. There's an ad on my article, and it says, "Feel your age with thicker, fuller hair in 3 to 6 months." But is that really feeling your age, or you're trying to act a different age?
Do you want thicker, fuller hair?
I'm good with my hair. Are you good with yours?
I'm okay with it. Yeah. I feel like I've figured out, the right formula to get it where I want it.
Good, good. You know what I'm not good with?
What are you not good with, Mark?
I'm not good with Doge.
Oh God. What did Doge do now?
Doge on Valentine's Day. I can't think of a better Valentine's Day than getting laid off from what you thought would be your stable government job. Uh,
Mm.
but they laid off 400 fish and wildlife workers in Florida. And so the higher ups at Fish and Wildlife in the state had the option of just letting the the Doge documents come down to them, to the fired people. Uh, but they decided, you know what, that we care for our employees,
Oh, they
and
did.
yeah, and we have relationships with them, and
Huh?
we know that this is catastrophic news. So they did a big Zoom video conference and let everyone know that this was out of their control, that they valued them, that they felt for them, and people were crying
Huh?
during the video conference.
This feels like a fairy tale. What actually happened, Mark?
No, no, that's what happened.
Wow. Okay.
Yeah. Yeah. So it was about 20 minutes long. And, you know, the employees that were getting fired, felt like they were important to the people they were actually working with. But what was interesting was afterwards, they still received the email after their direct supervisors were telling them all the good things about them, and they were so sad to see them go. The email just said, uh, your skills aren't up to par and you're fired.
Ugh. Gosh, and you know what sucks beyond the fact that Doge sucks is that so many of these people they're firing do incredible things for wild animals too. There's so many biologists I know that work for the federal government who've been fired. It's folks that have been promoted recently that get fired. And then they say your skills aren't up to par. And I feel like Doge's skills aren't up to par. They are making a mess of everything for no apparent reason. I don't know if there's method to the madness here. What do you think?
I think there is a method. The method is chaos and destruction.
Okay.
It's not a very good method. What's terrible too is, when they if they really wanted to streamline things, they would look at the military budget, which is like $900 billion a year, and they did, and they only found like 60 million that they could reduce. Meanwhile, back in the day, uh, Elon Musk was tweeting all around like, "We got to kill the F-35 program. We don't need manned aircraft anymore." Now we're actually Trump has commissioned a new fighter jet.
Ooh, is it
So,
part of SpaceX?
probably, I would believe. I, I don't
Good.
see why it would go anywhere else. Yeah, so I was heartened to see that the folks that were remaining in Fish and Wildlife in Florida, you felt compelled to pass this information along to the people that were getting fired. But yeah, just yet another example of this very non-surgical streamlining of government.
Well, speaking of government not
Ooh.
not working well, I've got a story. Well, I have two stories for you, and we're going to talk about them both, I think, at the same time because they're both wolf related. But one of them is federal government related. and it is related to the federal government funded wildlife killing agency, USDA's own Wildlife Services. Now, it took me a long time to get there, and I think that's by intent because no one knows this program exists. It's housed deep within the USDA. It's part of the Department of Agriculture, and they kill 1 million native wild animals every year, right around that number. It fluctuates a little bit, and they work mostly at the behest of the livestock production industry. So they're out aerial gunning coyotes for, $15,000 an hour in helicopters before calving season. And they're out there putting out those fun sodium cyanide bombs that have killed pets and permanently harmed children. But they do all of this stuff to maintain their quote unquote predator control program. And it's been shown to be completely ineffective, yet we all pay for them to do this anyway. And yet the Doge has not come for them yet, Mark. They have not come for them. And that enabled them to actually kill one of Colorado's reintroduced wolves in Wyoming. Because that's right, we pay for the government to kill wolves in Wyoming and in Idaho and in Montana and in all of the unfriendly wolf states. The federal government will actually just go out and kill wolves. And this Colorado wolf, it was one of the wolves that had been reintroduced from British Columbia. And it had made its way to Wyoming. As you know, wolves don't recognize state boundaries. They don't have to give their little visas to cross the border. Um, Not only did they kill this wolf, they're not 100% sure this wolf was involved in any predations. There apparently was a livestock producer there raising sheep and had lost 4 sheep, and he believes it was to a wolf. And so APHIS said this wolf, APHIS, sorry, Animal Plant and Health Inspection Services, which is, again, another layer of where Wildlife Services hides. Wildlife Services said, well, this wolf's kind of in the area, so we're going to go ahead and kill this one. And so they killed this British Columbia wolf without any real ties to the predation event, any real ties to knowing for sure this wolf killed any sheep at all. And we have no idea whether or not there were non-lethal deterrents in place. We don't know if these sheep were, left just completely unattended, but we did lose one of our Colorado wolves to the killing fields of Wyoming again.
Yeah, it's tragic. And I was just thinking, Doge is the aerial gunner. There's so much similarity between just randomly killing programs and randomly killing carnivores on the landscape.
Right.
What's really sad about this particular case and this wolf being killed by Wildlife Services is that I was starting to get a little glimmer of hope from Wildlife Services because they are, they have a program here to provide livestock guardian dogs to ranchers free of charge and paying the first year of vet bills. And so they're trying to help ranchers live with wolves in one state, and then the next state over, they're still killing.
Yeah, and to be clear, they do have a small budget to do non-lethal work, and that program is far more valuable than the budget they give it. But the majority of their funding really goes to the wildlife killing programs and then research on how to more easily kill wild animals that different producers feel are a nuisance in one way or another.
Yeah. Yeah. It needs to get the chainsaw.
Yeah, there we go. I'll wait for the chainsaw. And while we wait for that, are you ready for my next wolf story?
Let's go.
I know we're staying in Colorado today with my stories. There's a common thread here. We dabbled in Wyoming, scary. We're back in Colorado. And I am here to say that there was a wolf predation in Pitkin County. And this is the first confirmed wolf predation. And when we say predation, it's a wolf killing an animal on the range, and it's an animal of value to humans. So in this case, It is a yearling calf that was confirmed to be killed by a wolf. We're not sure if there were non-lethals in place, our guardian dogs, our electric fencing, range riders. We don't really have the full details on that yet, but Colorado Parks and Wildlife has confirmed that this yearling calf was killed by a wolf. Of note, there is another animal missing that they think could be a wolf, but again, it shows these operations happen on such vast acreage on over such large areas that it could be a wolf, or the animal could have just wandered off, or it could have died in the elements, which is the leading cause of free ranging cattle death. So we don't really know what happened to the second cow. What I really, really appreciated about this reporting is that for the first time, I saw in Colorado reporting wolf predation contextualized with cattle losses overall. And the reporter actually said, wolves are responsible for 0.001% of cattle deaths and only X percent of predation deaths. And we never get to see that. Usually it's a urban rural or it's some sort of attention grabbing headline. And I thought this reporter did a really excellent job of elevating the the issue while also contextualizing it for the reader, so the reader knows, hey, cows are dying all the time on the range from a lot of things, and wolf losses in the Northern Rockies and in Colorado are so minimal. And I'm really hopeful that we can work with some of these members of the livestock industry to get these preventative non lethals in place because they're so much more effective than killing wolves. And I think the wolf problem is, again, so minimal. So getting that education out there is really important.
Yeah, yeah, that was something that I did in my public comment on wolves at the last Colorado Parks and Wildlife Commission meeting was, hey, please, please, please put this in context with other ways that that cows and sheep die, and also put it in context uh, with whatever else I was going to say.
Put it in context with all of the other things. Yes. Let's
Yeah.
let's
No,
yeah.
there was something really good there. But
Uh-huh.
anyway, but also a really big shout out to Courtney Vale with the Rocky Mountain Wolf Project. I know she spent a long time with that reporter hammering home, putting it in context, and so that reporter heard, and I'm glad that it made it to the final uh, copy of that story.
Yeah. Yeah, and I know as advocates for us, it's so hard when we're talking to the press to really get the pieces of what we say into the final product of the story. I know for an interview I just did with Cowboy State Daily, I was talking about wildlife services and how much more effective non-lethals are, and then you just get a small quote and it doesn't have anything to do with that context sometimes. And I would love to see, again, more broad reporting that's all encompassing of the real issues rather than just getting some of those headlines.
Yeah, yeah, I think just reporting, right?
Yeah.
Reporting and allowing the reader or viewer to understand whatever issue that they are reporting on in a broader context. I I, I feel that that is missing in a lot of journalism that today. So I uh, I'm not going to hold my breath for that big
Gosh,
change to happen.
wow, what a sense.
But do you know who can hold their breaths very long?
Who, Mark? Who?
Seals.
Okay.
So this one comes from National Geographic, and it's called "How Do Seals Know How Long to Hold Their Breath?"
I'm waiting
Here's here's
now.
a well here's a question for you. When you're swimming in a pool and you're swimming underwater and you have that urge to come to the surface, why do you think you have that urge?
because humans aren't meant to be underwater and you could die down there.
That's fair. But is it your body sensing depletion of oxygen or an increased level of carbon dioxide?
Oh, I thought it was God telling me to rise to the surface. You tell me.
Yes. Yeah. Well, that's exactly what it is.
Okay.
Along with we feel when we're having that panic, got to get to the surface, we're feeling elevated levels of carbon dioxide in our systems.
Oh.
So there was a study that was just done where the seals they had to swim under a 200-foot long passage. And then there was all the fish they could eat there. And then they weren't forced to go there. These were wild seals. They could come and go as they pleased. And where these fish were then there was like a big box over them, over the water. And they changed the levels of oxygen in there.
Huh.
And so they were able to determine most likely seals can not only feel the increase in carbon dioxide, but they can also monitor the amount of oxygen in their blood.
Ooh, that's
It,
interesting.
yeah, yeah. So when they were reducing the amount of oxygen in this room, the seals weren't spending as much time in there. And so there's been other studies that have been done, but they weren't quite on this scientific level as this one was. And so they're really trying to understand, well, what is it like, how is it physiologically, how are they able to feel these differences in oxygen levels? And they're not quite there yet, but it's a really cool step in the right direction. And here's another really interesting bit in this article is they were monitoring how what seals do underwater, and they found that one of the seals that they tracked in the wild a couple of years ago could dive down almost 2,000 feet.
What?
Yeah, and
Crazy.
seals ascend at about 4 feet per second. So if they'd only respond at a very low oxygen level, they'd never make it back. They would just die. And
Yeah.
so what happens too with like free divers, human free divers, is that as they're coming up, that we can't quite understand how much oxygen is left, and so oftentimes on their way back up, they'll just black out, and if someone wasn't there monitoring them, they would drown.
Yeah.
But seals aren't doing that.
Seals are better than us at free diving, I guess, huh?
that that they are. So they're hoping to repeat this study uh, in another controlled experiment. But really interesting how you know we think we're so great because we can build buildings and airplanes and do all these things and destroy the environment and all these fun things that we do, but we can't monitor oxygen in our blood, so like
You can.
animals do really cool stuff and have really cool abilities. And so I highly encourage anyone to read this article and learn a little bit more about how seals swim underwater.
Oh, I love it. I love it.
Yeah, and it's a good segue too, because our interview, we're going to be swimming underwater in there as well.
We are taking a dive for our interview, so stick around for that, I guess, huh? Well, I am excited to welcome our guest today, Emma Helverson. She's the executive director of the Wild Fish Conservancy. And last week, I attempted to explain to our listeners how hatcheries are just a band aid, really, for southern resident killer whales, and that they are not effective long term, and nor are they effective at feeding starving orcas. And I am really excited to have you here because Wild Fish Conservancy does all sorts of great work around wild salmon. And we know that wild salmon are directly connected with the health of our southern resident orcas. So, welcome to the pod, Emma.
Well, thanks so much for having me, Sam. I'm really excited to be here. And Mark, yeah, do you want me to just jump in, or how do you want to?
Oh, we can always meander if you'd like, but I'm happy to jump in too. How did you come to the wild fish work? I'd love to know that first before we start peppering you with questions.
Yeah, it's interesting because I did not grow up in the Pacific Northwest. I grew up on the East Coast, and I'm a proud East Coaster in Pennsylvania, but in, a region where when I went fishing, you couldn't eat what you caught because of acid mine drainage and just, be living in a region that's so, still has its beautiful aspects, but is much more developed. And I actually, coming out of college, studied environmental science and had an opportunity to take a $9 an hour internship in Alaska, furthest west I had ever been in my life, and skipped over half the country I'd never seen and landed there as like a 22-year-old in a small town with no car, working on an internship in a wild fish nonprofit that was owned by two people who had worked previously for the government. And it sent me into some of the most amazing, just wilderness and streams, and seeing salmon firsthand, juvenile salmon, adult salmon returning and spawning, in the river below my feet, as I'm standing on a bank. And it honestly, it's in the same way that I think many people in the Pacific Northwest have these types of stories about their experience with salmon or with, species like orcas. It just completely changed my life. And I actually took a long detour before I made it back to the Pacific Northwest, but I kind of serendipitously started working with Wild Fish Conservancy, and it's just been the most kind of perfect fit for my background, and also for kind of the love of salmon that was really instilled in me through a $9 an hour internship in the middle of nowhere. So this is both a plug for doing things that make you a little bit uncomfortable because they might change your life, but also speaks to just salmon and why they're so incredible.
Yeah, salmon are incredible. I've been joking with other biologists that fish are often, the gateway drug to other animal issues. And my very first environmental job was entering data on Santa Ana suckerfish. So I was sucked in literally that way and never looked back. So I agree. Again, $9 an hour data entry job, but I thought, oh, I can dip my toe in the wildlife water with fish. So I know, Mark, you're impressed with all of my all of my puns right now.
I'm struggling not to jump in with a pun.
I'm really
Please
proud of
do. If I'm being honest, please do. But one of the things that's interesting about that experience, and that I find is interesting now that I'm working in, fish conservation, but so much of our work, because we're a wild fish group that focuses on, so our organization's mission is really the protection, restoration, and recovery of the Northwest wild fish, which of course is, and their habitats. So that expands so much further than salmon. But because salmon and steelhead and bull trout are in such dire straits because of their very unique connection with humans, they are a species that we spend a lot of our time focusing on, even though they are not the only fish that needs support. But fish in general, they're just not as charismatic as, a big killer whale or, other species that are just easier, I think, for the public to understand. And so I do think that's an interesting thing about people who fall in love with salmon, but also one of the struggles to protecting them because, we don't see them. They're underwater. They're these huge populations. And I think that's a tiny piece of the story with southern residents, but don't want to get off track there.
So I did not get paid $9 an hour to swim in the same pathway that y'all did. But so I really don't know much about fisheries and how it works. But to a layperson, it seems like we need more fish. We have fishery, we have these hatcheries, and then problem solved. Why is it not so cut and dry that way?
Yeah, yeah. And in particular, your question is kind of about fish in general. I'm going to bring it back to salmon just
Sure.
because that's kind of the issue we're talking about today. And one thing maybe to just like for anyone listening, so Washington State, which is where we're based, we really work from California to Alaska because salmon, which, I find that particularly people I meet on the East Coast don't always realize that salmon, one of the things that makes them so difficult to recover and protect, and but also so just like genetically important and ecologically important is that they spend their time in rivers. They're born in rivers as, small juvenile salmon, and then they travel all the way out into the ocean to feed and grow and take advantage of all these nutrients in the marine environment. And then they travel back to the rivers, in some cases within 1 feet of where they were born, to lay their eggs and then just die and to give their bodies back to the environment, essentially. And so, kind of to your question, why are they so important? Well, for one is, wild salmon, Pacific salmon, of which there are 5 species, are a keystone species, meaning that there are literally over 100 different animals in our ecosystems that depend on wild salmon. And that's why the killer whale issue is kind of, sometimes people say, well, you're a wild fish group. Why are you focusing on the southern resident killer whales? Isn't that like kind of outside of your purview? But when you have a species like the southern residents, who their diet is, predominantly salmon. They're salmon specialists, and 90% of their diet is one specific type of Pacific salmon, Chinook salmon or king salmon, which, have been the biggest historically. So they're the most calorically dense. And, when you see killer whales starving to death, that doesn't just mean you have a killer whale problem. That means you have a salmon problem. And so one of those important reasons of, we need salmon, because they literally sustain our ecosystems. They're in our trees. They're in our forests. If we didn't have salmon, I don't even know what the Pacific Northwest would look like, to be honest. And then on top of that, humans have now come to the Pacific Northwest, or have always been here. So we have indigenous peoples who have been depending on them for food for millions and millions, well, thousands and thousands of years. And then we also, of course, now have this complicated economy that is dependent on salmon. I think like a $9 billion economy. And so salmon are very complicated. Pacific salmon are the most funded endangered species in America. We spend more money to recover and protect wild salmon than any other species. A lot of that money goes to Washington, where I live and work. And Washington has the largest salmon hatchery program in the entire world. And when you look at the Fish and Wildlife budget in Washington, how are they spending money to protect fish and wildlife, which includes salmon? 50%, half of their budget, goes to managing hatcheries, which we're going to be discussing, and managing fisheries. And one of the things we know from our government, when we look at, well, why are salmon doing so poorly, there are really 4 major causes of decline. They call them the 4 H's, which are habitat loss, hydroelectric dams, which block fish passage, which in my opinion are just a form of habitat, and hatchery impacts and harvest impacts. And so it's always insane to me to think that you have the species that we're investing more money than any other species, and so much of that money is going into 2 of the major causes of decline for those species. But so I think the simple answer is, and I'll just take really long amounts of history and just truncate it really quick, but kind of the bet that the Northwest made, over the last century is, what we need to be able to modify the habitat. We need dams, we need energy, we need roads, we need to construct buildings and towns. And we recognize that, modifying habitat could possibly or would likely harm wild fish abundance. But kind of the bet we made was we can use hatcheries to artificially make up for that difference. And so it's not an inherently evil idea, but what we have seen over 100 years is that there is not a single example of hatcheries that have rebuilt, resustained, or any salmon populations that have been declining towards extinction. There are some examples, very rare examples. You should think of like like a hospital emergency room, where populations that have declined to maybe even single digit species, like from, again, thousands and thousands of fish down to maybe having 10 left. This is just a hypothetical, where you can use hatcheries to prevent extinction, maybe complete extinction, but you will never use a hatchery to recover a population. And we can dive into those examples, but the most simple one is wild fish carry 10 million years of genetic diversity. They've been returning, with some exceptions, to the same exact rivers. So they are a literal local reflection of the rivers in which they are born. So the real question is kind of this idea of who, if we, wild fish are the most likely to survive, particularly when we have climate change and these big challenges. But that's kind of just a crash course on the history of hatcheries, which is very truncated. And I'd be happy to come back and talk more about that or bring others in. But just kind of a bet that we made that really hasn't paid off. But here we are 100 years later, and we're just trying the same strategy over and over again.
That was much better than my truncated history that I tried to give last week, Emma. And I think for our listeners that are so much more used to talking about mammals, I think that they can relate to the piece where so much money is put into these fish because they're harvested. But there's also a huge commercial element too, where the fish are bought and sold. So there's so many different layers as far as these fish and the dollars that go in. So hatcheries do produce more fish. Why aren't these fish the right fish?
Well, yeah, there's two different questions. I thought you were going to say the right fish for killer whales, but in general, like
The right fish for killer whales was what I meant to say.
okay.
The killer whale was implied.
And I guess what I would say is, a lot of hatcheries are a very political issue because of that economic piece that we talked about. Even though wild salmon are pretty much from California to Alaska in crisis, Chinook, which we're going to be talking about today, being one that everywhere you look are just crashing. Even in Alaska, we actually are petitioning to list Chinook in the Gulf of Alaska right now as a threatened or endangered species, kind of asking the federal government, look at your own data, look at Alaska's data, and tell us if you believe that these species, deserve that additional protection. And I think that at least to people who, typically think of Alaska as this, very, Alaska doesn't have those same challenges that we have down here with, dams and so much habitat loss, but they're still experiencing the same reduction and depletion of their wild abundance. So it's, I guess the point I'm just trying to make, it's a coast-wide crisis for these species. And I guess to get to your specific hatchery question, in general, hatcheries are not an evil tool, but when you put fish in hatcheries, when they are reared in a building, when they are fed, pellets from they're fed from pellets that fall from the sky. They're protected from predators, so they do not have to do things in the early parts of their life that wild fish do. A wild fish comes out of its egg, and there could be a sculpin just waiting there, ready to eat you in the first 2 seconds of your life. And so you can just see that already they're having genetic adaptations that are different, and it's always hard to explain just how severe those changes can be. But even within one generation of a fish, going from the wild to the hatchery, you see genetic changes in its DNA. And it's just because hatchery fish are better at living in hatcheries and wild fish are better at surviving in the wild. And when it comes to killer whales, again, there's, the number, and I'm assuming you probably have talked about this killer whale issue, that for the southern residents, the number one cause of their decline that scientists have agreed across the board is lack of available prey. And it's two factors. It's not just the abundance of their prey, it's also the size of their prey. Because again, I talked about Chinook, which are 90% of their diet, used to be 100 pounds. You have these older Chinook that spent more time in the ocean, so they would grow to these enormous sizes, and that is why killer whales evolved to feed on those specific fish, because they're the most lipid rich, they're the most calorically dense. But we don't see 100-pound Chinook anymore. In fact, we have shrunk the average size of Chinook. I believe it's by 50% in just 55 years. We have shrunk the average size of Chinook. And today, my understanding is the average, like coast-wide, is like 10 to 12 pounds. And in a genetically biodiverse system, you would have some Chinook that would leave their rivers, go out in the ocean for 3 years, and some Chinook, those 100-pound Chinook, those Chinook were just genetically predestined to go out for maybe 7 years, 8 years before they would come back. And so there's a couple different factors that have contributed to this reduction in size. And one of them is the way that we fish, which I can talk about in a minute. And the other, when we just talked about this genetic diversity, is hatchery fish. And so what we know, scientists have been able to look at basically the prey preference of these killer whales and determine, what are they actually selecting for? We know that they don't have those 100-pound Chinook available to them anymore that they've evolved with. But what that science shows us, which is really interesting, is that even though those biggest fish are no longer available, they are still selecting for the biggest fish available to them. And so those are fish that are more in that 4 to 5 year old range, staying in, the ocean for 5-ish years before returning. What is one of the reasons why scientists have been concerned that our primary strategy for recovering killer whales, at least in Washington state, has been to produce hatchery fish with this idea that we can just supplement, the prey availability with hatchery fish, is that hatchery fish tend to be smaller. When you are feeding an animal a lot in its early part of its life, it grows quickly in when it's, a younger fish, and then it grows slower as an older fish, which is different than how their wild counterparts kind of evolve. But just, what we see in the data is that hatchery Chinook tend to be closer to a 3-year-old or a 4-year-old wild salmon. And so it's interesting because there's this chart that's really boring. It's not interesting, but I really love it because it's fascinating. It shows you what are the fish that are available in the ocean, and then it shows you what are the whales selecting for, and they're totally opposite. And so the question is, okay, we know that they need more fish. We can definitely use hatchery fish to put more Chinook out in the ocean, but are we producing more of the fish that the whales are not selecting for? So that's one of the first questions that scientists are asking about this hatchery strategy. And then the second question, which you kind of just talked about in your intro, Sam, is that, again, hatcheries are known to be the number one cause of, or not the number one, but one of the top causes of decline for wild fish. And so across the board, scientists and many orca scientists have said, hatcheries are not a strategy they're not a strategy for recovering wild fish. So they're certainly not a strategy for recovering orcas because of the ways, and I talked about the genetic impacts of hatcheries, but there are facility effects, there are dynamics in fisheries. So there are lots of ways hatcheries can affect wild populations, but let's just say we know that that's not a long-term solution for recovering Chinook, and what we need is to recover Chinook, let alone more diverse and older life histories of Chinook. So that's kind of a lot. I'll stop there and just see if anything I'm saying doesn't make sense. But
my brain is trying to keep up. So is what you're saying the fish that the whales want to primarily eat are larger,
yeah,
and so what they're doing, so they're targeting these fish, which then reduces the number of large fish, which then we need to increase the number of hatchery fish, which are smaller, and so this is kind of continuously shrinking the large fish on the seascape while we're replacing with smaller fish. Is the main reason an efficiency issue with why orcas focus on larger fish? It probably takes a lot of energy to catch a fish.
yeah,
Okay.
yeah. If you think about it, Mark, and there's one factor I didn't introduce that's also contributing to this shrinking. So I'll get there. I'll talk about that next, which kind of brings those two things into perspective. But what you said is generally true. But if you imagine, okay, you're a killer whale. Maybe it took, you could go out and catch 100-pound Chinook, and now you have your daily caloric intake. You have everything you need for your body for the day. But now you only have 6-year-old Chinook available to you. So now maybe you have to catch 10 6-year-old Chinook. So you're foraging longer for the same amount of energy. But we know that even 6-year-olds are not really available. Predominantly what's available are these 3 and 4. And so each time you go down in age class where you're getting smaller fish with less lipid, less calories, whales have to forage longer and expend more energy to catch the same amount of caloric intake. And so it's easy to see how they're starving when they have to forage longer just to get the amount of energy that they need. And one of the things that
Really quick oh, sorry, I was just going to say for our listeners, I picture someone running on a treadmill and you have to run at 5 miles an hour. And at first you're given a snack every hour, but then you start lowering that time. You're getting less food, but still having to run that same amount. So I think that for folks that can look at the caloric intake piece, it goes across mammals, right? Like if I'm exerting the same amount of energy for a tiny, tiny scrap of food, I'm going to starve. And that's what's happening pretty much with whales. Yeah.
Yeah, and one of the craziest parts, and people like Dr. Deborah Giles would be a better person to talk about this, but what she's kind of told me is what they're noticing is that because these whales are basically starving all the time, they're spending predominantly all of their time foraging. And that brings in those other factors. So we know that, for example, noise is a problem for whales, noise pollution, because they echolocate for their food. And so when you are starving already, when you have less and smaller food available to you, and then all of a sudden you have all this noisy environments, that makes it even harder for you to forage in an already bad situation. Toxins is another big issue for these whales because there are just toxins in our environment, PCBs, and they have been stored in these whales in their blubber. And so when they are starving to death, they're eating into these food reserves that are then pulling toxins that otherwise wouldn't be a problem for them into, their bodies. And just to stop on that point, we see other whales that are not salmon eaters. So like the transient killer whales, another type of killer whale that shares a range with the southern residents, but is much more extensive. The transients are traveling much further around the coast, and they eat pinnipeds, seals. They're eating higher up on the food chain. They are actually much more concentrated in these toxic chemicals, but they're not actually declining. Their population is doing well because they're not starving to death. They're not pulling those toxins into their bodies. So the food piece is huge, but what we have seen is because they're spending so much time foraging, they're not participating in these social activities that are so important for, these incredibly intelligent species. If you think about, you know, like I always think about elephants when I think about whales, typically they would be, playing and spending time doing things that are not just foraging. They would be having interactions with other pods that used to happen much more frequently, these super pods, because the killer whale population has kind of these three distinct families that are called pods. And I don't know why, but they label them J, K, and L, and they're distinct. They all have their own languages. But when they get together in these super pods, they all share like a universal language, and they get together and they play and they interact. All of those social behaviors that are so important to the species, they're not happening, and they're not happening as frequently because these whales are just spending all of their time foraging for food.
Man, I love that commonality, being able to speak language that's universal. It's so cool. I Have we seen any size reduction in the whales, or has there been any change in their culture as far as still are they 100% salmon dependent in these resident pods? And we haven't seen them stray to. I would imagine this all is a cultural thing, right?
Mhm.
And so they haven't been like, "Hey, we got to eat something else now."
Maybe humans. No, kidding. But no, and that's a super common question that people ask, because you would think, and I think that to me just speaks so strongly to just genetic evolution, right? But they don't. They are continuing to, they are salmon specialists. Again, 90% of their diet are Chinook, and that really hasn't changed. There are in that 10%, because they are traveling from all the way down in California, all the way up through British Columbia to like just outside of Southeast Alaska. They do have varied diets throughout their range, which is another reason why trying to figure out how to get them the right salmon at the right times at the right size is just such a complicated game. But I know they do eat other things like I think some squid, some coho, some chum, but predominantly it's Chinook salmon. And again, even though those bigger fish aren't available, they're still predominantly sourcing Chinook. So I do understand. I think that some of their patterns are changing. I often hear from the killer whale scientists who follow them that, they're not spending as much time in Puget Sound, for example, in the summer. And I believe that is the time when they seem to be the most in need of food. But yeah, and I believe there is also a part where their jaws are different than the transient whales that eat pinnipeds. So they just like, again, physically are evolved to very specific species. But yeah, a lot of people are like, well, can't they just eat something else? And the answer they've been telling us is no, this is what we eat. And the other piece I want to get to, because I really think it'll illuminate the story more, is that you cannot talk about hatcheries without talking about fisheries. Because I've already debunked this long held myth that hatcheries are a tool to recover wild fish. They just have not proven that to be something that they're capable of. Hatcheries are capable of producing fish to increase populations. And so really the role that hatcheries play is to sustain fisheries, to sustain harvest at the levels that we harvest. And again, it's wild that, and I'm not saying we shouldn't have any salmon harvest, but it is crazy to think that I'm not aware of really any other, I'm sure there are some, but threatened and endangered species threatened with extinction that we harvest for commercial profit. Obviously, some of that harvest is subsistence for, indigenous communities and local communities, but most of it, predominantly, most salmon that leave rivers are harvested in the ocean in what we would call mixed stocked fisheries, which means, we have salmon from up and down. Let's just talk about Chinook because that's what we're talking about. Chinook from Oregon all the way up to Alaska, including all through British Columbia, West Coast, Vancouver Island. They leave their rivers, they go out into the ocean, and they migrate just like birds to areas in the ocean. In the case of Chinook, right outside of Southeast Alaska, this what we call the nursery, this food-rich environment. And so these Chinook are feeding and rearing for anywhere from 3 to, however, 3 to 7 years. And what we changed as humans, in addition to the hatcheries, is how we fish. And so we used to fish, indigenous peoples, I should say, used to fish for thousands and thousands of years sustainably in rivers where salmon return, in or near rivers. It wasn't until about a century ago that we started shifting harvest out into the ocean. We were chasing fish because, why wait for them to return when we can just go out where they are all the time? And that simple change doesn't seem like it should cause a huge difference, but it really did. And here we are 100 years later, and we're really starting to see the impact of these mixed stocked fisheries. And there's a couple different factors, and one of them is the killer whale issue. But the first is that now, today, many of those populations leaving our rivers are not healthy. And so we are just fishing. When we fish in the ocean, there's no way to protect those weak stocks. So we're just harvesting kind of indiscriminately, even though the fishers who are doing that harvest have the greatest conservation, ethics and intentions. It is just impossible when you have all of these fish mixed together from different regions. So it creates an ecological crisis, creates an equity crisis, because now we have to decide who gets to fish for those fish. We have actually litigated over issues related to this because that fishery I'm discussing outside of Southeast Alaska, 97% of the fish that get harvested there come from outside of Alaska, non-Alaskan rivers, even though that is a fishery where every fish that comes out of it will be sold as a wild-caught, sustainably certified wild Alaskan Chinook. And the reason we litigated over this fishery is because not only was the harvest rates in that fishery so high, they were over harvesting Chinook that it was depleting Chinook populations on the Columbia River, which seems confusing, but 50% of the fish caught up there in Southeast Alaska would actually return to the Columbia River, which is just, historically a massive Chinook producing system, but also because they were harvesting fish that were the priority stocks for these southern resident killer whales and harvesting them at rates that were much too high for the survival of the whales. And so I'm not going to talk too much about that legal issue, but since then, recent research has come out by some of our leading regional scientists pointing out that the number one cause of decline for southern residents is that prey availability. But the number one problem we need to solve are these mixed stocked fish that are intercepting, basically if you picture birds migrating, taking them before they can return. And so historically, when we didn't fish there, these fish would go up, they'd grow, sometimes to these, 100-pound sizes, and then they would travel back down the coast into the whales areas and they would feed on them. And so we are not only intercepting them, but where the size piece comes in with the fisheries is that imagine if you're playing tag and you play for an hour and Sam plays for 1 minute. Who is the most likely to get tagged, during that game? Well, Sam is going to play for a minute and bow out, so she's probably going to be fine. But if you have to be tagged for an hour, you might not be okay. And it's
Obviously,
the
you
same.
haven't played tag with us.
Yeah, that's
I
fair.
can make
That's
it.
fair. But for these fish, it's the same dynamic. If you're an 8-year-old Chinook or a 7-year-old Chinook, you would have to evade fishing pressure for 7 years. And whereas a 3-year-old Chinook swims around for 3 years, they have the most likely chance. And so that shrinking factor I was talking about is actually, there are many things that contribute to it, but that is one of the most human caused and one that's been the quickest, that's caused that decline the quickest, because we're only allowing our smallest, youngest Chinook to return to our rivers to produce more small, young Chinook. And we're basically harvesting out all of these large Chinook, which are the ones that the whales need. And so that's a huge problem. And that is what these scientific papers have been pointing to. We cannot be fishing in the nursery. We need to protect these stocks. And for these whales, we need to be taking actions that restore these larger life histories. We need to restore diversity. And so together with hatcheries that just harm the genetics of wild fish across the board and fisheries that are harming the genetics of fish in terms of their age and size, what's interesting and what I really wanted to get across today is when we look at the science that tells us what the whales need and what is harming them, and then we look at the policies that we have in places like Washington, where Washington has conducted, multi-year orca task forces. Back in 2018, the governor kind of convened this 2-year process to figure out what do we need to do to save killer whales. And the number one issue that was not discussed, that was off the table, was harvest. And because of that, the number one issue that we landed on was hatcheries, which again has just been the strategy that is the easiest to turn to when you don't want to change anything that humans are doing, which is hard. I'm not belittling that, but that is just and so as Sam said, it's a better, easier band-aid than asking people to stop fishing. And so that's where we are. Washington State's primary strategy is to use hatchery fish to offset this loss of abundance for killer whales, but that doesn't address the size piece. It doesn't address the long-term sustainability of Chinook, and as a result, the long-term sustainability of the killer whales. And even in that fishery example I gave that we litigated over, the government acknowledged in that case that the fishery was over harvesting fish and that the survival of the killer whales and underlying Chinook populations were in trouble. And guess what they decided to do in that case? They gave even more money to Washington State to increase hatchery production. And the last piece I'll throw out there, which is a little bit just probably getting into the weeds, but by design, the way that these international fisheries work in the ocean, because they're Canadian-U.S. agreements under a larger treaty called the Pacific Salmon Treaty, that basically says, okay, any fish that spends part of its life in Canada and the U.S., we need to decide together, who gets to harvest them, where, when, and in what amount. And what that treaty is supposed to do is to prevent overfishing and to ensure equitable sharing of fish to all communities, related to where they originate. And this is my opinion, and I think it's shared by many, that the treaty is really fundamentally failing to do either one of those things. But in that treaty, the way that those fisheries work is that if you picture a pie, when they're deciding who gets how many fish and when and where, they split up this pie, right? A fish is a fish. It's just, you get these many, you get this, you get this. The killer whales do not have a slice of that pie. They are not, if you look at the Pacific Salmon Treaty that is renegotiated every 10 years, most recently in 2018, you will not even find mention of the southern resident killer whales one time. Control F. But the way that the fisheries work is, if more fish are in the system, everybody gets more fish. The pie stays the same, but everybody gets to harvest more. And so that is the big elephant in the room that nobody who is making these decisions around hatcheries really wants to discuss. That, I already talked about all these scientific concerns, but then we also look at the political systems we have in place, and basically we'd be producing more fish that are unlikely to get to these whales because it's just going to increase harvest in the fisheries. And I think that I think there are some people who are who believe in the hatchery strategy in a very sincere way, but we've also seen a lot of evidence that hatchery strategy was really also, how should I say this? I want to be as polite as possible, but some commercial fishing, some recreational fishing interests really saw that issue as a way to increase hatchery production in a way that they have not been able to justify because of all of the science we have about how hatcheries are already causing a lot of harm. When you increase the size of your hatcheries, you're increasing the impact of those risks. But now we have this crisis. We have to feed killer whales. And I think some people, and I'm saying that because I've seen evidence of people admitting that, they saw the killer whale issue as a good way to advocate for hatchery increases. And so my big goal, and I know I've been talking for a while, so I'll shut up after this, but my big goal is to really educate the public, to educate people in public positions in Washington and British Columbia at a coastwide scale to really understand these issues, because we've basically since 2018 started this ball rolling where we've just been relying on this hatchery strategy. And on the other hand, we have science saying that everything we've done to date, if we keep doing it exactly the way we're doing it, these whales will be functionally extinct within 40 years. And within 100 years, there won't be potentially any members of this population left at all. And so it's scary to me that this is our last shot, I guess is what I would say. Right now, the decisions we make this year, this decade, in the next 5 years, the ways we invest, if we don't rewrite the ship and start turning towards what science is telling us we need to be doing, I'm pretty worried about the survival of this population.
So, I mean, this is just so much to absorb, and and also raises questions. Like, I know on a personal level, I absolutely love fish. Like, as far as any kind of meat protein goes, fish is my number one. I just came back from Mexico. I'm plant-based in Denver, but whenever I go to the beach, I do eat fish, and I limit myself by only eating when I'm next to water that may be producing those fish.
Mm-hmm.
So, are there methods that can be used to sustain these populations where we're selecting for these hatchery fish versus wild fish, or should we shut down commercial operations until we restore these populations?
Yeah, I thank you for asking that question, because it's a really important one. Because I think when we talk about these problems without talking about the solutions, which is something our organization is really focused on, is always, taking the science and saying, okay, we can critique what we're doing, but what are the solutions? How do we do it better? And I think people are fearful that this means there just won't be fishing, that it's whales versus fishing. And I understand that fear, but I think it's a false narrative. And what kind of so we've been talking about killer whales, but really we're talking about salmon. How do we recover salmon? And what the science has consistently shown for decades is that we need to shift out of the ocean, shift these large, massive fisheries back to the way that we used to fish, shifting back to those indigenous fishing practices that worked for thousands and thousands of years sustainably. And again, they were fishing in or near rivers of origin, waiting for those fish to return fully mature at their largest size after those fish have migrated home, which means killer whales have had, and other predators and other species have had the first opportunity to harvest, or harvest, but to feed on those fish. Harvest is such a weird term, but it's just what we use in the fish world, probably to avoid saying killing. But giving those species that have depended on those fish forever the first opportunity to feed. And that is actually important, just as a side note, because they've co-evolved. So killer whales are just as important for salmon as salmon are for killer whales. But when those fish return, the way that indigenous communities used to fish was in or near rivers of origin with selective tools. And when we say selective tools, sometimes you hear place-based fisheries, sometimes you hear terminal fisheries. But really the key is, first, when you allow fish to return, you have so much greater control over understanding what populations are those, right? So if they're returning to the Columbia River, you know that they're Columbia River fish. And then from there, you still have mixed stocks. You still have maybe Chinook that are doing better and are maybe harvestable, swimming side by side with Chinook that are not doing as well, or steelhead that are, critically endangered. And then in the case of the Columbia, which isn't the case of all rivers up the coast, you also have that hatchery dynamic, because that's where most of this production for killer whales has been taking place, in the Columbia. And and so what science has showed us is when we're, it's a 1-2 punch. You get out of the ocean, you fish in or near rivers of origin, and then you fish with selective fishing gears. And one of the ways that we have been trying to help allow for this transition is to look into what are these tools that have worked in the past, and they're tools like fish traps and reef nets and kind of beach seines. And the way that they work, or the way that modern contemporary selective gears work, is that essentially they allow fishers to harvest those fish that they want to be targeting, and releasing fish that they don't want to be harvesting, but with a high chance of survival. And so gill nets, for example, are a tool, again, not an evil tool. Gill nets have been used for a long time. They're a great tool in some places, but when you have fish that you need to be able to release because they're not doing well, gill nets are not a great tool for that exact purpose, because the fish are ensnared by their gills or by their fins, and they just have a lower likelihood of survival. And so on the Columbia, for example, when and I'm just speaking right now about like non-tribal fisheries right after below Bonneville Dam, which won't mean a lot to people not in Washington, but the non-tribal fishery, they fish with gill nets. And even though the state recognizes that most of the threatened and endangered fish that they're harvesting shouldn't be harvested, they also recognize that if they're released, they're not going to survive. So they just tell the fishers, harvest them anyway, and then we will just reduce the number of days that you can fish to basically ensure we're not doing too much harm to those ESA listed fish. So that is just not a sustainable solution, because we shouldn't be doing any harm to populations that are on the brink of extinction. And so tools like fish traps have shown that because they are passive, because they work more like a maze, fish are kind of traveling through a maze of nets, not touching those nets, not being exposed to air, not being exposed to overcrowding, which are the things that in most common contemporary fisheries are causing high mortality rates in fisheries. And then essentially the way that these modern gears work is we have this kind of passive chamber technique that allows fish to be kind of corralled into a live well. You can use an underwater camera to identify what species they are. If they're one you want to harvest, you harvest them with a dip net. And if you want to let them go, you just open the door and they swim right through. And what our peer-reviewed data has shown over 3 peer-reviewed papers between 2016 and the present is that there's no essentially, and this is in an experimental setting, but we found essentially 100% survival of the fish that we're releasing as far as we can track them upriver. So over a 7-day migration, over 400 kilometers after moving through the trap, are surviving, which, in a real life setting would be to go back into their rivers and to spawn. And then allowing the fishers to harvest, those healthy species or hatchery fish that are produced for harvest. They're intended to be harvested. So we do that work on the Columbia. We're also doing work in British Columbia with First Nations on the Skeena River, the Fraser River and the Campbell River estuary area. And they're not harvesting hatchery fish, but they're trying to avoid doing harm to species like steelhead and Chinook and harvest species like sockeye. But it's it's amazing to finally see these working models of these types of gears. We do some of that work. There are other groups that are doing similar projects in other areas, but this is kind of the model of, we know that if we keep fishing in the ocean, it's going to harm orcas. We see that even fisheries in the ocean, like, for example, the Chinook fishery, so that Southeast Alaska fishery I talked about, one of the biggest Chinook fisheries in the world, kind of comparably, the second or first biggest, depending on the year, is the California troll fishery. That fishery has been closed for 2 years straight because the populations have just reached a point that we can't even justify harvest. And I've been on the docks in San Francisco area talking to fishers, and it is absolutely devastating for those communities. I mean, they get weeks, maybe days notice that they're not going to be able to go out. And so kind of the way our organization has been thinking about this issue as a whole is, this is inevitable. If we keep fishing the way that we're fishing, if we keep producing hatchery fish to kind of mask this problem and hold up these unsustainable fisheries, that's the model we've been using, and that model is failing. And what we need is like complete systemic change, which everybody hates change. I can hate change. But in this case, that's what the science is showing us that we need. That's what the species are telling us that they need. And so one of our biggest efforts that we're kind of working on is a new public campaign called Let Our Salmon Come Home. And the whole idea of it is we need to basically restore power. Well, it's an ecological campaign, but it's also about restoring power to local communities over the destiny of their salmon populations. Because when you fish in the ocean, we've talked about all the ecological problems, but it's also undermining all of those local efforts that are happening from Alaska to California on a river level to restore fish. Taking down the Snake River dams is absolutely needed. But if we're extirpating Snake River Chinook in or pushing them to extinction in ocean fisheries, it won't matter if we take down that dam or not. We need those fish to return and feel the full benefit. And through this way of shifting harvest into the ocean, we've removed that control from local communities, including indigenous communities who predominantly, because of the way that we have kind of relegated them to their traditional fishing areas, still fish in or near rivers of origin. And so they are, in my opinion, in many cases, the most affected by this mixed stock dynamic because they are at the very end of the line when these fish returned. And really the kind of promise that our government has made is, we'll give you funding for hatcheries so that you can increase the number of fish returning, when really, to me, that's a false promise because there are other things we could be doing that would play a much bigger role in shifting that control and that access back to local communities. And maybe their choice would be to use these selective fisheries, but really that's the whole beauty of it. We need to get more fish on the spawning grounds and we need to let local communities have more control over these populations. So that's my pitch. But the cool part about it is it's just a win-win. And it's a win for salmon recovery. It's a win for orcas. It's a win for rebuilding those older life histories. It's a win for local communities. But it's the people that we cannot leave behind are those fishers who do fish in the ocean. And that's why we need to be working on those selective alternatives. Again, it's going to look different, but we need to be able to bring people along. So it's a big change, but the killer whale story is just one small piece of that, but they're a big piece of it. And they're kind of the canary in the coal mine for the salmon crisis that we see. So,
well, thanks, Emma. And my last question is something cool you taught me. And that was, what's the difference between how does a fisher person tell the difference between a wild fish and a hatchery fish? Mm-hmm. And then tell us how we can find you online and all that good stuff too.
Cool. Yeah, and I actually find that a lot of people don't realize this, but hatchery fish, so when you look at a picture of a wild fish, pay attention to its fins because there's an adipose fin, which is the fin kind of between the tail fin and the dorsal fin. That fin they clip when hatchery fish are being prepared. They just clip that little fin off, and that is what's interesting. Is my understanding is the reason that they started clipping fins is so you can tell the difference, so fishers can tell the difference, but to make way for these they call them mark selective fisheries, so fisheries in which a recreational fisher or a commercial fisher can harvest a fish, look at it, say this is a hatchery fish I want to keep, so when you're doing those selective projects, that's part of how a fisher in a system with hatchery fish would know which fish to select. And that's why sometimes when we have these big funding crises, that's one of the first things that we fear will go away, because it's really important that we can distinguish between wild and hatchery fish. But, big changes are needed. And one thing that's, I'll end with, because I started with talking about being an East Coaster, there is nothing comparable to just the cultural love of wild salmon on the East Coast that I've ever found. I mean, of course, people love the environment. They love the species there. And I do too. But the Pacific Northwest, I mean, we don't agree. Many people have different ideas about what needs to be done. But I mean, every person like up and down the coast is putting their boots on the ground and they're shoveling the dirt to do whatever they can, whether they're, Alaska indigenous communities or commercial fishers, recreational fishers, people who don't even eat fish, but just love to, snorkel or just know that they exist. And that's what gives me faith, even though the world is weird, because people really care and so much depends on these solutions, and we know that they exist. So I'm actually strangely optimistic in this time, and that's how I want to leave it for the listeners. And I guess I would say if you want to learn more about Wild Fish Conservancy, go to our website, wildfishconservancy.org, and reach out to me if you have any questions. I love talking about this work. I'd be happy to talk about it with anyone who wants to know. If you want to know more about this new campaign, Let Our Salmon Come Home, this is, again, something we've been building up to build a scientific and kind of foundation for years since I was honestly like in elementary school. People on my staff have been working towards this, which is so cool because I know I'm just like droning on now, but given all the weird things in the world, given people I know like Sam have kids that they're toting around in the back of their cars while they're doing podcasts on how to save the planet. These are multi-generational issues. And I look at the people that I work with who have been doing this since, I was 1 year old, who have, in many cases, made it possible for us to still turn this ship around. And so now I feel this enormous responsibility at 36 to make sure that 50 years from now or 30 years from now, people that aren't even born yet are going to say thank you for, the work that you all did, people like you and people that I work with. So I'm very optimistic despite all the odds. And yeah, reach out. I'd love to talk to you, and we need all hands on deck. So
Yes, well, you have me hooked, and I fully. Sam's shaking her head, but no, I absolutely support what you're doing, and are so thankful for the work that y'all do and for the optimism that you are keeping in this fight to make sure that these fisheries don't go away in the future, and that everyone gets their own share of these beautiful creatures. And we are so thankful for you coming on the podcast today, and I'm sure we will continue on this, for me, lesson in fisheries and hatcheries and all things aquatic like this. I'm absolutely fascinated, so thank you again. This has been an episode of the Wildlife Wire with me, Mark Searles, and my co-host, Samantha Miller. Thank you for listening.